right, so today we are going to talk about standard form of a linear equation. So we've already talked about slope-intercept form as well as point-slope form. So we've got several things up here that we are going to learn how to do. We're going to write linear equations in standard form, change between forms, and then we'll use our standard form to find intercepts and to solve problems. So standard form of a linear equation is ax plus by equals c. So I'm going to go ahead and write that down in this space where we're writing them all out, where a is greater than or equal to 0. So that means your a is not going to be negative. So you're only looking at 0 or bigger for the a value, which is the coefficient of x. It says a and b can't both be 0. So if a is 0, then b can't be. If b is 0, then a can't be. A, B, and C have to be integers whose greatest common factor is 1. So integer, this part tells me no fractions or decimals. The greatest common factor is 1 just tells me that when I look at A, B, and C, they can't all be divisible by the same number. So if they're all even numbers, then it's not in standard form because you could divide everything by 2. They would have a common factor of 2, for instance. Okay, so we're going to put up at the top of the page the other two forms that we've learned as well. So go ahead and write out your slope-intercept form and your point-slope form because you should hopefully know them by now. So our slope-intercept is y equals mx plus b. Our point slope is y minus y1 equals m times x minus x1. If you don't know these, I would suggest creating 3 little flashcards, one side that says the name of the form and the other side that has the actual form on it so that you become accustomed to looking at these and can quickly identify and know the form that you're supposed to be using. So in example 1, I've got 8 different equations here, and we're going to go through and check them and identify what is in standard form. So when I look at this first one, so it's definitely lined up. I've got ax, by, c. My a is greater than or equal to 0 because a is 3. These aren't both 0. And there's nothing other than 1 that is a common factor for 3, -1, and 15. So this is a standard form equation when I look at it. When I look at the next one, they're lined up nicely, my ax plus by equals c type format. However, this one is no because a is not an integer. My a value is a fraction, so this is a no. I cannot circle it. This one, there's all kinds of things wrong with it. I don't have it in the right format as far as how things are lined up. I've also got fractions, so this is definitely a no. This next one, I have ax. I don't have any y's. So what that tells me is that y has a coefficient of 0, which means b is 0. Which is okay as long as a isn't 0 too. And in this case, a is 1. 1 is an integer. It's greater than or equal to 0. So this is in standard form. Even though there's no y there, it's definitely still in standard form. All right, so what I would like you to do for your first task that shows me that you understand what we've just talked about, of these remaining 4 equations that you see, only one of them is actually in standard form. So what I want you to do is think about it, review what's up here as far as what the requirements are, and then go ahead and select which of these 4 equations is also in standard form. All right, so the correct answer is this one, y equals -2. In this case, my a is 0, but my b is 1, and 1 is an integer, and then equals -2, no common factors, so this is in standard form. This one, x plus 3y equals 5, 6, is a no because of the fraction. This one is a no because of the decimals. And this one up here is a no because this one is the tricky one. A lot of people pick this one. This one is a no because a is not greater than or equal to 0. Your a isn't positive. So here it was the fraction. Here it was the decimals. And then here it was the fact that my a value was negative. So y equals -2 is in standard form. The next thing that we're going to do is rewrite each of our standard form equations into slope-intercept form. Once we've done that, showing our work, we're going to graph the equation. So I'm going to do A, and then you guys are going to try B, and then we'll reinforce with C. So here, if I want to rewrite it in slope-intercept form, this means I need to get y alone. Because y equals mx plus b, y is all by itself. So in this case, that means I need to subtract x on both sides. This is why we did a lot of work with literal equations, because when we're trying to get y by itself in an equation, that's what we're doing. We're solving a literal equation. So I have y alone now, but on the right side, I've got 3 minus x. Those are not like terms. I can't combine them. And if you want it to be in slope-intercept form, I write the x term first. So negative x, and then this was a positive 3, so negative x plus 3. It then says to graph the equation. So when it's in slope-intercept form, I can then say, okay, my slope is -1. My y-intercept is 0, 3, because remember, it's always 0, b, and b in this case is 3. So when I go to graph it, I'm going to plot my y-intercept, so 1, 2, 3, and then I'm going to use my slope. -1 could mean one of two things. It could mean my rise is -1 and my run is +1, or it could mean my rise is +1 and my run is -1. So this instance would mean to go down 1, right 1. And I could continue going down 1, right 1, down 1, right 1. Or I could go up 1, left 1. So up 1, left 1, up 1, left 1, so on and so forth. And so then, I apologize if this doesn't come out straight. It's hard to do with this technology up here. There we go. We've got our graph. Okay, I want you to go ahead and do the same thing on B. You need to get your y completely alone, so it's just a plain y, not a negative y, hint, hint. And then graph your equation. All right, so let's go ahead and check your work here. Couple different ways that you could go about this. You could either move the y over here and move the x over here, or you could subtract the 10x on both sides, which is what most people think to do. The other way is honestly probably better in this case, but I would say most people do it this way, so I'm going to do it this way. So then I have negative y on the left. Again, these are not like terms. Do not tell me this is negative 16x. You can't combine x's with plain numbers. That's just negative 10x minus 6. Then I need to get rid of this negative, which means I need to divide everything by negative 1. So that gives me y by itself. Negative 10 divided by negative 1 is positive 10. Negative 6 divided by negative 1 is positive 6. So here is my slope-intercept form. Now I'm going to graph it, which means my slope is 10, or 10 over 1. My y-intercept is 0, 6. So go to 0, 6, plot that point. I do not have enough room to rise 10 and run 1, but I do have enough room to rise negative 10 and run negative 1. So that's what I'm going to do. So I'm going to go down 10 units, left 1 unit. So down 10 units would be to here, left 1 unit would go to here. And this is going to be really hard for me to connect because it's so steep. I'm going to try my best. Oh, I missed. I'm so sorry. It's terrible. Hopefully yours looks better than mine on your paper that's actually flat. All right, so now just to reinforce, if you missed B, you really need to pay attention here as we go through C. So first thing I'm going to do is I'm going to subtract the 9x on both sides. So then I've got negative 2y on the left side, because those cancel. And then I've got negative 9x plus 2, because those are not like terms. So then, once we have those over there, we need to divide by negative 2. Now be careful. When you do this, we have to divide everything by negative 2. So negative 9x divided by negative 2. The negative 9 and the negative 2, the negatives become a positive. Don't forget to bring the x with it. Then I have positive 2 divided by negative 2, which is negative 1. So y equals 9/2 x minus 1 is my equation, which means that my slope is 9/2 and my y-intercept is 0, negative 1. So start at the y-intercept, 0, negative 1. And then this means I'm going to rise 9 and run 2. So up 9 units to here and right 2 units. And then I do have enough room if I want to also go down 9 units and left 2 units. And then I've got my nice line there to check. All right, so when we have standard form, one of our methods for graphing is to get the y alone so that it's in slope-intercept form and to graph from there. As you can see in choice C, that's not always the easiest way. Because sometimes we end up with these, messy fractions. We have to remember to divide out both terms. So sometimes it's easier to just simply find both intercepts. I call this the cover-up method, but it really is the intercept method. So when we find an intercept, we do that by plugging in 0 for the opposite letter. So to find an x-intercept, plug in 0 for y, to find a y-intercept, plug in 0 for x. Now, the reason why I call it the cover-up method is because if you take your finger and cover up the ax part, that does the same thing as plugging in 0 for x. So if you just take your finger and cover up this 2x, all I have, and this is for finding my y-intercept, I cover up the x term. That leaves me with 3y equals 24. Divide both sides by 3, and I get y equals 8, which means that my y-intercept is 0, 8. When I go to find my x-intercept, I also cover up, but I cover up the y term. So put your finger so that it's covering the 3y and look at what you have left. What you have left is 2x equals 24. So then I divide by 2, x equals 12, and so my x-intercept is 12, 0. Now, the intercept method is great because you can simply plot the 2 points and then connect them. So 0, 8 would be right here, and 12, 0 is slightly off the graph, but it'd be about right here. And then connect the dots. Okay, so I would like for you now to go ahead and use this cover-up intercept method to find both intercepts for the equation in part B. So I'm going to ask you to find the y-intercept and select it, and then I'm going to ask you to find the x-intercept. All right, so for the y-intercept, and notice how I always label my work, I would strongly suggest that you do the same because it can help you when you go back to look to figure out where your mistake might be if you make one, if you've labeled what you're doing. So y-intercept means I'm going to cover up the x term, so put your finger over this x plus part, and that just leaves us with 8y equals 24. So divide both sides by 8. I have y equals 3, which means my y-intercept is 0, 3. Then, when I go to find my x-intercept, means I cover up the whole y term, so put my finger over the plus 8y. That just simply leaves me with x equals 24, which is already solved. So my x-intercept is the ordered pair 24, 0. Now, I need to change this scale here because obviously I can't just go 2 tiny little spaces over. I'm going to have to change what I'm counting by in order for this graph to work. So I'm going to change it so that I'm going to count by 4s maybe. So let's see, 4, 8, 12, 16, that still only gets me to 20. So I'm going to count by 6s then on the x-axis. So 6, 12, 18, 24. Make sure you're changing this on your copy too. And then finally 30. So this would be -6, -12, -18, -24, and -30. So 24, 0 would be this point right here. I did not change the scale on my y-axis because it was okay the way it was. 0, 3, I could plot right here. And then connect my dots for my graph. All right, last one. Same method. When I go to find the y-intercept, I'm covering up the x term completely. So when I cover up the 9x, I'm left with negative 2y equals 2. Divide by negative 2, and y equals negative 1. So 0, negative 1 is my y-intercept. When I go to find my x-intercept, I'm covering up the whole y term, so that leaves me with 9x equals 2. Divide both sides by 9, and x equals 2/9. So that means 2/9, 0 is my x-intercept. It's okay that it's a fraction. This is really small. Half of 9 would be 4.5. So this is, really small. It's less than a half. It's just barely above 0. So when I go to make that dot, I'm going to make it just barely to the right of the origin. My y-intercept, 0, negative 1, right down here. And connect the dots to get my line. Notice that this was the same equation that I had in part C of example 2, and notice that my lines do pretty much look the same, even though I used a different method. Okay, so now that you know how to change from standard form to slope-intercept, you know how to find the intercepts, we've graphed it, we've pretty much met most of our learning goals here. So now we just need to make sure we understand how it applies to real life situations. So that's what we have in example 4. Sudie is making a large batch of granola to sell at a school fundraiser. She needs to buy walnuts and almonds to make the granola. Walnuts cost $3 per pound and almonds cost $2 per pound. She has $30 to spend on these ingredients. A, write an equation that represents the different amounts of walnuts X and almonds Y that Sudie can buy. So I know that however much she buys of the walnuts, and this would be in pounds. So X and Y are the amounts. This would be in pounds because that's what unit we're measuring in. However many pounds of walnuts I buy, I need to multiply that by its cost per pound. So $3 per pound times the number of pounds of walnuts. This, the 3x, would represent how much total I spent on the walnuts. But I also have almonds to spend money on, and it's the same idea here. They're $2 per pound, so I'm going to add in plus the cost of the almonds, $2 per pound times the number of pounds of almonds. And I know that this has to equal the $30 that she has to spend. So notice how we have information and we've written it in standard form. So this is often what happens when it looks like you have two slopes. We had the per pound twice. So that, not always, but a lot of times, that is an indicator that we're going to write our equation in standard form. All right, part B, we're now going to graph this equation. So you can use either method. I personally think the cover-up method is easier, but if you prefer converting to slope-intercept, we can do that. So I'm going to do the cover-up method first. Y-intercept, I cover up the x's. So that gives me 2y equals 30. Divide both sides by 2, and I get y equals 15. Then for the x-intercept, I cover up the y's. So I get 3x equals 30. Divide both sides by 3, and x equals 10. So y-intercept is 0, 15. X-intercept is 10, 0. Again, I'm going to have to change the scale on my y-axis just to make sure that I fit. So I'm going to do 3, 6, 9, 12, 15, which would mean this would be -3, -6, -9, -12, and -15. So my y-intercept, 0, 15. Now that I've relabeled, that can go here. My x-intercept, 10, 0, goes on my x-axis here. And then I can graph the equation. All right. C, if Sudi buys 4 pounds of walnuts, how many pounds of almonds can she buy? So 4 pounds of walnuts. Remember that X is the amount of pounds of walnuts. So I now know that that value is 4. So this is the last thing that I want you to try on your own is go ahead and use 4 for the number of pounds of walnuts in your equation and use it to find out how many pounds of almonds she could buy. All right, so pounds of walnuts, again, was X. So that means I am plugging in 4 for the X in my equation. 3 times 4 plus 2y equals 30. And I'm going to solve for y because y stands for pounds of almonds, which is exactly what I'm trying to find. So order of operations, I do this multiplication first. 3 times 4 is 12. Now to get y alone, I'm going to subtract the 12 on both sides here. That gives me 2y equals 18 because 30 minus 12 is 18. Divide both sides by 2. And I end up with y equals 9. So, because this is a word problem, make sure that you have a label when you're doing this yourself. 9 pounds of almonds is what she could buy. All right, last question. What is the x-intercept? Interpret its meaning in this situation. So we already know the x-intercept because that's the method that I chose to graph part B. So I don't need to do the work again. If you chose slope-intercept here, then you would need to do this work again. But I already did the work. So 10, 0 is my x-intercept. What this means, again, we relate it back. X is pounds of walnuts, y is pounds of almonds. So X, pounds walnuts, y, pounds of almonds. So all I'm doing is writing a phrase that uses this. So what this means, the meaning in the situation is if Sudi buys, don't need an apostrophe there, the English teachers would get me. If Sudi buys 10 pounds of walnuts, she can't buy any almonds. Or you could even say, if she buys 10 pounds of walnuts, she buys 0 pounds of almonds. That would be the same thing. All right, hopefully you feel set up for success. Please, please, please reach out if you need help.